Okay, we left off right at the bottom of this page, right? We had just talked about what the IQR represents from the box plot. It is the width of the box. So now we are going to learn how to calculate whether or not something is an outlier. So now we're going to have a numerical rule instead of just, it kind of looks like it could be. So we use what is called the 1.5 times IQR method. I want to visually show you what's going on first before we do this calculation. So IQR is the width of the box. So this right here is my IQR. I'm going to measure that 1 and then another half. So I'm going to try to go half as big from either edge of the box. Oh, wrong button. So I'm looking to see, do I have data values that are farther away from the edge of the box than 1.5? Thank you. I thought I had her last period. Give me just a second. Yeah, I had her 5th period, so I'm not sure where she is 6th period. Okay, I'm so sorry. You're welcome. That's okay. All right. To determine whether or not something is too far out that it qualifies as an outlier, I want to know how far away from the middle half of the data we are. So with my really bad highlighting example here, does it look like we're going to have any low outliers? No. Does it look like we might have a high outlier? So just from a visual, it looks like we have some data that is more than 1.5 times the width of the box away. Why 1.5? The honest to God truth, the statistician that came up with this said, well, 1 didn't look far enough and 2 looked too far. I am not kidding. That's how they came up with this. They said 1.5 seems like, if we've got data that's 1.5 boxes away on either side, that still feels like it's reasonably close enough to the middle. But more than that, and I start to go, well, that's weird. And that's really what we're looking for with those outliers is that's really odd. All the rest of it's here and that guy's over there. So 1.5 times IQR, way too small outliers will be smaller than whatever Q1 is, the left side of the box, minus 1.5 times the IQR. What was our Q1 again? And what was our IQR? 5. And we need to do 1.5 times the IQR. So we've got 61.5 minus 1.5 times 5. What'd you come up with? What is 61.5? 54. Did we have any data values that were smaller than 54? No, so that matched what we saw visually. We don't have any data values smaller than 54, so there's no low outliers. To check to see if there's any high outliers, we need to go to the other end of the box. So we're going to go over to Q3, and we're going to move farther to the right. So we're going to add on to the right side, and we minus from the left side. What was our Q3 again? 66.5 plus 1.5 times the IQR. So 1.5 times 5. 74. Did we have any data that was larger than 74? What was that data value? 77. So 77 is an outlier. And this actually affects how I draw my box plot. So we're going to make a slight variation to our box plot. It is perfectly fine if you did your box plot in pen, because we're just going to kind of scribble out what it should look like. I'm not scribbling out the whole thing. So 77 is an outlier, so we're going to represent the outlier with an asterisk. And my box plot, my whisker on my box plot, still has to end on a data value. What was the next largest data value? 72. So that's where my whisker is going to end now. And the whisker would not extend out this way. So if there's outliers, they get represented with asterisks. Doesn't matter whether they're on the high end or the low end. You can have more than one outlier. It's possible to have 3 or 5 outliers. It becomes less likely because the more things that you have that are farther away from the center, that's going to make your standard deviation go up. That's going to make your IQR go up because now you have a lot of data values on either side that are far away from the center. But it is possible to have multiple outliers. And then the whisker would end at whatever data value is not an outlier but is the next biggest, or here on this end is the next smallest. So far, so good? All right. Ashmita is 63 inches tall. How does her height compare with the other AP Stats students in her class? What's special about her being 63 inches tall? That is the median. So how does she compare to her classmates? If they were supposed to line up by height, how does she compare? She'd be right in the middle. So about how much of her class is shorter than her? Right around half, right? How many are taller than her? Half. Yep. She is the median value, so she's taller than about half the class, taller than about 50% of her classmates, and she's shorter than about 50% of her classmates. There's nothing to write down for this next little bit, but I want you to look at the dot plot up at the top of the page. No, top of the page that you were on. Still page 15, that's okay. The dot plot that we were working with up there. How would you describe the overall shape? Not the whole distribution, but how would you describe the overall shape of this distribution? Does it look approximately symmetric, balanced on the left and the right? Does it look skewed to the left or to the right? Skewed to the right, so the larger values, correct? We can see this. It's a little bit hard to see, but we can see this with our box plot. What percent of the data is between here and here? 25%. What about here and here? 25%. Notice, that's all crammed together. We got 25% of the dots in this little space right here. When I look on the other side of this box, the other side of the median, here's another 25%, and it's more spread out. And then we still have this tail off to the edge. My whiskers look about-ish the same size. This one looks a little bit longer to me, but not by much, and that might just be my bad artwork. But the median is very clearly closer to the left-hand side of the box. So the data is more spread out as we move to the right. I can kind of see this tail. If I had one whisker much longer than the other, or if the median is obviously closer to the left-hand side or the right-hand side, we can see a skew there. Not quite as obvious as with our histograms, but you will be asked at some point in statistics to describe the shape where all you have is a box plot to look at. All right, let's go ahead and flip it over to page 16. There were three main learning topics for this lesson. First one was defining exactly what is and is not an outlier. The most common method is the 1.5 times IQR method. Low outliers, smaller than 1.5 on this side of the box, on the left side, or larger than 1.5 of the boxes on the other side. There is also a standard deviation method. For standard deviation, low outliers would be whatever the mean is minus 2 standard deviations. For high outliers, it would be whatever the mean is plus 2 standard deviations. So this is another way to calculate outliers. This one is the most commonly used method. If it doesn't say which one you're supposed to use to check for outliers, you use this one. If they want you to use the standard deviation method, they're going to say. Box plot, big ideas on our box plots. Median goes in the center of the box. Q1 and Q3 are the edges of the box. I don't like that they're pointing at the wrong spot. My minimum is technically this guy, right? But he's also an outlier. So that's the minimum except for that one weird outlier down there. So he's not really the true minimum, but he's the minimum for my data set other than any outliers. You do want to title your box plots. So what is this a box plot of? What variable are we looking at here? You do not have to label each of the pieces. You do need to know what each of the pieces are. Where do you find the median in a box plot? Where do you find Q1, Q3? What do the edges of the whiskers mean? You should know that, but when you draw a box plot for me, you don't have to label. This is the median. This is Q1. Last thing that we need to cover is comparing distributions. And we're going to practice this here in just a second on the Check Your Understanding. I want to give you guys an explanation of what I want. Then I want you to try it, and then we'll compare. So comparing distributions. Do you guys remember SOX? We want to use SOX when we're comparing our distributions. And you want to compare each one of those 4 pieces. You want to compare the shapes. You want to compare the centers. You want to compare the spread or the variability. And you want to compare outliers. Every single piece. When you make a comparison, do you typically just report something? Is that a comparison? Like Ms. Bolt is 67 inches tall, and Ms. Bolt's husband is 70 inches tall. Is that a comparison? What would I need to include in that if I was going to make a comparison? The difference. Who's taller? Who's shorter? You want to use those comparative words. So greater than, less than, bigger, smaller. You want to make sure that you're actually using those comparison words, or it's not going to count as comparing the distributions. Now, when it comes to the shape, there's only so much you can do about comparing shapes. If they're both approximately symmetric, you're going to say they're both approximately symmetric. If one is approximately symmetric and one is skewed, I just have to kind of report those differences. They have different distributions. One looks like this, the other looks like that. If they're both skewed in the same way, but one is much more skewed off to the right, then I could make more of a comparison there. This one is more skewed to the right than this one, although it's also skewed. So yeah, shape, outlier, centers, variability. Whatever measure of center it is that you use for one distribution, you have to compare it to the exact same measure on the other. So I couldn't compare the mean of one to the median of the other. That's not apples to apples. So mean to mean, median to median. If I have access to all of my summary statistics and I get to choose, when would I go with the mean as the measure of center? When it's approximately symmetric. When would I go with the median? Skewed or outliers. If it's skewed or outliers, I'm going to use the median. If I only have access to the median, then that's what I have to use if it's approximately symmetric. If I don't have access to the mean, I only have one option. But if I have a choice, approximately symmetric, we go with the mean. Skewed or outliers, we go with the median. For variability, when should you talk about the ranges? When should you be comparing the ranges? If you don't have anything else that you can talk about. If you don't have any kind of summary statistics, you don't have the IQR, you don't have the standard deviation, then we'll talk about range. She's not in this class period. I don't know where she is 6, but it's not here. When should you go with the IQR? The IQR tells us what again? The width of our box plot. This is the middle half of my data. We use this when we have used the median to talk about the center. We're going to use the IQR to talk about the spread. So if you have skewed data, if you have outliers, that's when you want to talk about the IQR as far as your measure of spread. If your data is approximately symmetric, so you're using the mean to talk about the center, then you should use the standard deviation to talk about the spread. Because the standard deviation, remember, this is typically how far my points are from the mean. So talking about standard deviation with median doesn't make sense. Because it's how far away are we from the mean, not how far away are we from the median. Does that make sense? All right. Down below this, there are 2 box plots. University of Michigan, Michigan State. I would like for you guys to write a couple of sentences comparing these 2 distributions. Make sure you compare all 4 pieces. Make sure you use comparison words, less than, greater than, bigger, smaller. And make sure you incorporate context in there. I'm going to give you guys about 5 minutes to work on that, and then we're going to compare. how would you describe the shape for the University of Michigan? Or sorry, not University of Michigan, for Michigan State. How would you describe that overall shape? Skewed to which way? Skewed to the right. From the middle over here is a lot bigger than from the middle over here. Skewed to the right. What about University of Michigan? Also skewed to the right. The median is very clearly closer to the left-hand side of the box. Is one of them more skewed than the other? Yes, which one's more skewed? Yeah, Michigan State is much more skewed. So in this case, I can make a comparison there on the shapes. They are a little bit different. So we got to make sure to hit socks. Here's what I said to start off my comparison. The distribution of points scored by, and then I named the two. Is a lot of words, but I'm getting my context points right there. Context is always a big deal. On the AP exam, when you're describing a distribution, there's these 4 things you have to hit, plus context and comparative language if you're comparing. If you forget one of these 4 pieces, but you remember your context, that's almost always still good enough for an E. If you get all 4 of the pieces, shape, center, outliers, and spread, but you forget context, it'll usually go from an E to a P. Yes? What is, oh, good question. E is essentially correct. P is partially correct. So an E would be like 100%, and they only have E, P, and I. Essentially correct, partially correct, and an I for incorrect. Good question. I'm sorry, I didn't realize I was already using those little shortcuts that I hadn't explained what they meant yet. So context is super, super important. University of Michigan is skewed to the right. Distribution of points scored by Michigan State is less skewed right. Michigan State University, no, it is more skewed right. I need to change that to more, sorry. I'll do that here in a second. How would you compare their centers? First of all, what measure of center do we have to use here? Have to use the median. Why? It's skewed, but I can think of another reason in this context why I would have to go with the median. Yeah, it's a box plot. I don't have the mean. I don't have all the raw data. I can't find the mean. They didn't tell me the mean. I have to go with the median because it's my only option. When I have a choice, I would still choose the median on this one. How do the medians compare? They're exactly the same. I can't use a less than or greater than. They are exactly lined up. If there is a difference at all, even if they're close to being the same, I would still report one as being more than the other. Even if I can't be precise about the numbers, I'm going to ballpark what the numbers are and talk about greater than, less than. So I make sure I get that comparative language in there. What about spread? What measurement do I have to use to talk about spread? Have to use IQR. For a similar reason that I have to use median, I don't have another option. But also because it's skewed data and I use the median to talk about the center. Once you decide whether you're using mean or median to talk about the center, you have already decided what your spread should be. If you go with mean, you got to talk about standard deviation. If you go with median, you got to talk about IQR. How do the IQRs compare? Michigan State has a larger IQR. You would ballpark that at about how big? Somewhere between 19 and 22, right? What about University of Michigan? That one looks to be about how big? 8, 9, 10, like somewhere in there-ish. So which one's bigger again? Michigan State. I'm going to make sure to use that kind of language. U of M has lower variability, there's a comparative word, than MSU with an IQR of about 9 points, which is less than MSU's IQR of about 21 points. I could have said more instead of less and switched it around the other way, but you got to get that comparison word in there. Do either of these distributions have outliers? No. How do we know? Yep. There's no little asterisks here. Neither distribution appears to have any outliers. I'm going to change that one word because that's bothering me. I want this to say more instead of less. All right, nicely done. What we're going to do next is a review activity to help us get ready for the test next Wednesday. Your homework's due on Monday. You should have picked up a test review on your way in the door. I don't grade test reviews for points. The test review is something that you do so that you are well prepared for the test. If you choose not to do it, you will struggle on the test. Like, that's just a guaranteed. The style of questions on the review is very similar to the style of questions, especially the multiple choice, which we have not done a lot of practice with so far. Half the points on the AP exam come from multiple choice. So we're going to do multiple choice practice, and about half your test grade on every test is going to be coming from the multiple choice. I want you guys to arrange yourselves into groups of 2 or 3. And if you flip over to page 17, that's the activity we're going to be working on. In your groups of 2 or 3, I'm going to assign you one of the data displays that we have learned about. Box plots, histograms, dot plots, stem plots, split stem plots, one of those. And you are going to create this display. There is paper and construction paper, white and construction paper on the back table, along with markers, colored pencils, rulers, and tape. We're probably going to have to debrief this, go through all of the pieces on Monday, and we'll do that quickly because you guys probably have just enough time to make your data display. So get yourselves in groups, and I will assign you a type of data display.